Welcome. This is Math Expert video tutorials, and this is the second video under ordinary differential equations. So under this we are going to look at solutions to a differential equation. Solutions to a differential equation. Now here, as we said, the only prerequisite that you need under this course is your calculus 1 and your calculus 2, which is what? The differential calculus and the integral calculus. In fact, all that we are going to do here, you just need your calculus 1 and your calculus 2, and that is all. Alright, so as far as this topic is concerned, solution to differential equation, I will need your differentiation very well. Alright, so we are going to verify whether a given function is a solution to a differential equation. So all that we are going to do is that, for instance, with this question, we have been given a differential equation here, and we also have a function. Why is this a function? This is a function because we don't have a differential equation in it, but this is a differential equation because we have a first order equation in it, and it doesn't matter the order. Any order of it is a differential equation. Alright, so what we are going to do is that in this differential equation, you see that you can have a first order in it, a second order in it, or a third order in it. So when you take the function, then you differentiate it the number of times that you can get such order of differential equation in it. And when you do the substitution and you subtract and you get 0, or when you get 0 is equal to 0, then we say that it's a solution to the differential equation. As I'm giving you the theory, you may not know what I'm talking about. But let's see. Let's go through the questions and see how we are going to solve it. Alright, so the first question is, we have a differential equation y prime plus 2xy is equal to what? 0. This is a differential equation, and we have a function of what? Y in terms of x, which is equal to c e raised to the power base squared. Alright, so looking at what we have here, we need only the first derivative of this function in order to do the substitution into it. So the first derivative will give you y prime is equal to, now, differentiation. So to differentiate it, this is just a constant. They see here is a constant, so no problem about it. So you know that you differentiate everything here. I just want to go straight to the point for you, but please go and revise from your calculus 1. Alright, so here what we do is that you repeat everything here, then you take the derivative of what? Of the power, which is that. So y prime is going to be equal to c e raised to the power negative s squared. Then this will multiply this, the differential of this is what? Negative 2s. So here we get y prime is equal to negative 2s c e raised to the power what? S squared. Alright, so having this, that means that we have the y prime here is the same as this. So instead of repeating this differential equation by bringing the y prime, we do the substitution to 8. So here we are going to have negative 2s c e raised to the power negative s squared. That is what? Y prime plus 2s plus 2x. Very good. Now 2x, we know that this y is already given here. Alright, so this y is already given here to be what? To be c e raised to the power what? Negative what? S squared is equal to what? 0. So I hope you can see something. What we have here is the same as what we have here. Therefore, we are going to get 0 to be equal to what? 0. Because here is what? Negative. And since we are having a to be 0 is equal to 0, it means that the given function is a solution to the differential equation. Alright, thank you, and let's continue. Trust you. B. We have the differential equation 3y ds to be equal to 2s dy. And we have the function to be, so this is the differential equation. But before that, let's leave it well, okay? Let's leave it in the form dy ds, or what? Y prime. So here, 3y ds will be equal to 2s dy. We can divide here by, because we want to get something like dy ds. So let's divide here by ds. Here by what? Ds. So we get 3y is equal to what? 2s dy ds. And this is the same as 3y is equal to 2sy prime. Very good. So having this, we can make y prime the subject. So we get y prime to be equal to 3y over 2s. 3y over 2s. So having this, then we can now go and pick the what? Our function, and take the derivative of this what? Function. Therefore, after that, then we come and do the substitution what? Into it. So we pick the function, and the function is s squared minus, s to the power 3 minus, just like that, equal to 0. So we have s to the power 3 minus cy squared is equal to 0. So having this, then we have to differentiate what we have here. So the best thing to do is to first make y the what? The subject, so that everything will be simple for you. So by making y the subject here, we get cy squared is equal to, send this one to this side, so you will be left with s cubed here. So divide here by c, divide here by c. So you get y squared is equal to s cubed over what? C. But while taking a square root of both sides, you're going to get square root of 3cx. 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 Now here, you can choose to say that 3c. We are saying that c is representing what? A constant. C is representing a family of what? Constant. Let me say that. A family of constants. And the 3 is also what? A constant. So we can say that everything here is just a constant. So y is equal to cx, because the whole of this is still a constant. Alright. And also, we can also say that here, this is the same as square root of c times square root of what? S. Square root of c is still a constant, so we can say that y is equal to c s to the power half. Then we take our derivative. Now we can take our derivative. So when you differentiate y prime, you are going to get alright. Due to what we have here that we are going to do the substitution to it, I would like us to not go by, but that is the idea, but let's ignore the idea that the whole of this is a constant, so we are representing it by c, because of this substitution that we are going to do to clear off something. Alright, so you don't worry, let's maintain it in it. Let's maintain that in it. So taking the derivative of this, there is no problem to it. So all that we do is that, okay, so all that we do is that we get square root of 3 over c s to the power half, which is the same as square root of what? X. There is no problem to that. Sorry. So let's take the derivative now. Y prime is equal to this is a constant, so we forget about it. So you just multiply this by what? This half 3 over c. Then This will give you what? S to the power what? Negative what? 2. Alright? And having this, we can say that in fact, everything here that we see here is a constant. So let's make it small so that it will help us. So the whole of this is C S to the power what? Negative half, which is the same as C square root of what? S. So y prime is equal to this. That means that we are going to do the substitution of this to this side. And we are going to get 3y over 2, 3y over what? 2s is equal to C over square root of what? S. And we can see that even if we send this to this side or send this to this side, we are not going to get it to cancel to get us 0. But all the same, we have y here, alright? And we know that y is equal to what? Where is it? We know from the question that y is equal to this, alright? So let's replace that by that. We know that y is equal to C. Let's represent everything here by C. Cs, all this over 2s is equal to C square root of what? S. Hope you can see what is happening here. Alright. Now, having this, we know that square root of C is still C. So here is square root of what? X. Alright. So here, let's see if we can cancel something to make it simple for us. Now, when we do cross multiplication, we are going to get 3C, this and this. So we get S. Alright? To be equal to this times this. So we are going to get 2CX. And now, we can clearly see that here we are going to get 3 is equal to what? 2. Now, since the left hand side is not giving us 0 and the right hand side is not giving us 0, or the left hand side and the right hand side is not giving us the same thing, in order for us to cancel out to get 0, we say that it's not a solution to the differential equation. It's not anything difficult. It's the same as what we have been doing. Alright, so this is not a solution to the differential equation. Alright, so let's move to the third part. We have y prime prime plus 2y prime minus 3y is equal to 0. Alright, so having this, we have this is a differential equation, and we have our function here, which is y is equal to c1 e raised to the power s plus c2 e raised to the power negative 3x. So, looking at the differential equation that we have here, we have the y here already. We don't have the first derivative, the second derivative. So what we have to do is that we have to go for what? The y prime and the y what? Prime prime. Okay, no problem. So let's go. Let's go for y prime. That means that we are taking the derivative of what? This. So y prime is equal to, remember your calculus 1. So this one, you get C1, this is a constant, so you will not do anything to it. This will remain the same because when you differentiate the power, you are going to get what? 1. Alright, so plus, here too, you write C2 e raised to the power, so you repeat everything, then you take the derivative of the what? Of the top, which is negative 3s. Next time, I'll do it straight away. Make sure you don't revise word. C1 e raised to the power s, this is going to give you 3. And you get negative 3 C2 e raised to the power negative 3x. Very good. Very good. So this is the first derivative. So you leave this one here. Then you go for what? The second one derivative, which is what? Y prime prime. So going for the second derivative, it is in the same way. You use the first derivative to get the what? The second derivative. So let's go for y prime prime. So differentiate this, you're going to get c1 e raised to the power s minus. Now, I'm going to do it straight away. You know that everything here will repeat, alright? So you differentiate the power here and you're going to get negative 3 as what we had here. So that negative will come and make here plus. So 3. So that 3, this 3, so you get 9 here. I'm going to get 9 C2 e raised to power negative 3x. Alright, so that's going to be that. But 9C2 is still a constant. 9C2 is still a constant. So y prime prime. You can say that y prime prime is equal to C2 e raised to power s plus the whole of this is still C1. So the whole of it is still a constant. So e negative 3x. Alright. So that's what we have for that. And even this is still what? A constant. So we can say that this will also be the same a constant. Constant times constant is still a constant. If you don't understand, that's it. Okay. So now let me name this equation 1, this equation 2. So we are going to do the substitution of equation 1, equation 2 into the what? The differential equation. So y prime prime is this. Do the substitution very well. CES plus C2E negative 3x. Alright, so that is that for that. That is for this side. Plus 2y prime. So y prime is the equation 1. Y prime is the equation 1. And that one too, you are going to multiply it. 2 will multiply the y prime prime. Y prime. So C1 e raised to power s minus C2 e raised to power 3x. Okay. Minus 3y. And the y2 we have it to be here. Alright, so this will multiply C1 e raised to power s plus C2 e raised to power 3x. Good. Equal to 0. So now let's see what we have. We know that we're going to get C1 e raised to power s, C2 e raised to power negative 3s plus, please watch, 2 multiplying the constant is still a constant. This is still a constant, forget about it. Minus, here too, this multiplying this is still a constant. C1 e raised to power s minus C2 e raised to power s, we are here, plus, don't forget the negative here will affect the inside, okay, minus C2 e raised to power, I'm forgetting to multiply the 3 by the constant because it's still the constant. Good, so that is that for that. Now let's see, what will answer what? What again? What again? You can see that this and this will not go. What again? Let's look at the one that will cancel each other. Okay, so let's see. This cannot cancel this. This cannot cancel this. So we are going to get something like C1 e raised to power s minus C2 e raised to power s minus C2 e raised to power negative 3s is equal to 0. Now, since the ones here cannot cancel each other to get you something like 0 is equal to 0, we say that, we conclude and say that it can't be a solution to the differential equation. It can be a solution to the differential equation, because if only you can get something like 0 is equal to 0, or the left hand side being equal to the right hand side. For instance, 2 is equal to 2. 2 is equal to 2. When you say this one here, you get 0 is equal to 0, or the left hand side equal to the right hand side. Since we are not getting that, we say that this is not a solution to the differential equation. Alright, so let's try our hands on the, please try it on your own, the last one. Try the last one on your own. Try it. I trust you, and I believe that you can. Okay. So we have a differential equation giving us y prime minus 6y prime plus 9y is equal to 0. Okay. And we have the function to be c1 plus c2s squared e3 to the power s. And we have to check whether or verify whether this function is a solution to the differential, or this function is a solution to the differential equation. Alright, so first of all, we need to go for what? Y prime. We have the y here already. The y is here. So y is equal to, let's expand. We get c1 e raised to the power 3s plus c2 e raised to the power s squared e raised to the power what? 3s. Very good. Then you differentiate this, you get 3c1 e raised to the power what? 3s plus, is that place positive or negative? Let's check first. We need to see whether it's correct or not. Alright, it's positive. So we are going to get here 3c2 s squared e raised to the power 3s. Alright, and as I said, this still c1. Or if you want us to maintain it, no problem. So still not affect anything. Alright, so let's go for the second derivative. Second derivative, you will differentiate this because the whole of this you leave it. So 9c1 e raised to the power 3s, 9c1 to the power es, plus this one to 339, 9c2 s squared. Oh, sorry. There is a mistake here. No problem here, there is a mistake here. And even in the first one, there is a mistake there. Okay. So this one you get this, but when you get to this side, this is a product rule. Product rule. Don't forget the differentiation. C2, block that one here. So this is a product rule. So leave this, differentiate this. You get 3 e raised to the power 3s plus. Now, differentiate this. You get 2s and leave this. That is product rule for you. So y prime is equal to 3c1 e raised to the power 3s plus. This one is going to give you 3c2 s squared. Hope you can see that. 3c2 s squared e raised to the power 3s plus 2c2 s e raised to the power 3s. Right, so I'm going to get something like that. Good. Now let's see how we can simplify this to the least. Y prime is going to be equal to. Please, the whole of this is c, is still c. So let's take that off and go our way. So here we get C is 2C, 3x. Now you can still maintain it in it, but I don't want it to be bunch of stuff. C2 x squared 3x plus 2 plus C2 x e raised to power 3x. You can't add this to this, so you leave it as such. Then we go for the second derivative. So we use the same thing. This will give you 3c1, okay? So I'm maintaining c1 e raised to power 3s plus here we can see that we are going to get a product rule here. Oh, this question. There is a product rule here. I hope you can see that. There is a product rule here. And that is, leave this one, differentiate this. And 3e 3s plus differentiate this and leave this. So that is the difference, the product rule there. And when you get to this side, it's still a product rule. C2, leave this, differentiate this, plus differentiate the s, you get 1, and leave e raised to power 3s equal to, okay, that's all. So y prime is equal to c1, we are simplifying it, plus, here you get c2 s squared, this 3 times this is still a constant, alright? E raised to the power 3s plus c2, the 2, still a constant, s e raised to the power 3s plus c2s e raised to the power 3s. You know the reason why I'm ignoring this. C2 e raised to the power 3s. So this is the second derivative. Please continue, okay? So we have the first derivative. Let's first name this equation 1, equation 2, equation 3. So we have the function, the first derivative, the second derivative. So what we're going to do here is that wherever you see y prime, put the value, put whatever you have there. Y prime, put whatever you have there. Y, put whatever you have there, and see what you are going to get for that. Alright. Whether you're going to get the left hand side to be the same as the right hand side, or you are going to get it to be 0 is equal to what? 0. So that is all for checking whether a given solution is a given function is a solution to the differential equation. Let's look at another special case of questions and we will be back to it. Alright, so that's another special case of the solution to a differential equation. So second question, for each of the following differential equations, determine the value of m such that y is equal to e raised to the power ms in, it's a solution. It's a solution. So A, so let's first look at the A. In the A, we have been given a differential equation, and that differential equation is y prime minus y prime minus 12y is equal to what? 0. Here, we need y prime and y prime to do a substitution. But God being on our side, we have been given a function here to be y is equal to what? E raised to the power mx. So this is the first equation. So we go for what? Y prime by taking the derivative of what? This. So you know how we do it. You repeat the whole of this, then you take the derivative of what? This. Alright. So here we are going to treat the m here as what? Constant that we are looking for, because the question is saying that is a value. Determine the value of m. So m is a value, so we are looking for it. So don't treat it as a function to say that this is going to be a product. I beg you, my calculus man, I beg you. Alright, so I prime is equal to e raised to the power ms. So here, when this multiply this, we get what? M. So y prime is going to be equal to m e raised to the power what? Ms, equation 2. Then you go for what? Y prime prime. And that is equal to, this is still a constant that we are looking for. So this is not a product rule. So this is going to give you m. You repeat everything, ms. Then the derivative of what? I don't repeat this. The derivative of the ms will give you what? M. So this is m. So you get y prime prime to be equal to what? M squared e raised to the power what? Ms. Equation 3. So now having equation 1, equation 2, equation 3, we are going to do the substitution to this. So here we are going to substitute it by m squared e raised to the power ms minus y prime is what? M e raised to the power ms minus 12y, and the y is e raised to the power what? Ms is equal to what? 0. So let's find m. So we get m squared e raised to the power So looking at what we have here, we can divide both sides by e raised to the power ms, e raised to the power ms. So e raised to the power ms Alright, so let's continue. That's it. So that's what you're going to have for that. And when you divide both sides by e raised to the power ms, e raised to the power ms, e raised to the power ms, those types will what? Cancel out to get a quadratic what? Equation. And when you take your calculator and you punch on your calculator, or you, whether you are applying the quadratic formula, we have factorization method and what method again? Completing of squares. Any of it that you apply, you are going to get m to the 4 and or what's negative 3. Alright, so looking at this, the question, the differential equation that we were having for that question, which is the A, is a second order equation. And you can see that if it's a second order differential equation, it resolves to what? It will resolve to a quadratic what? Equation. So looking at the second question here, you can see that the second question, you are still using the function of this. So you need the second derivative, then you don't need the you need the first derivative. You don't need the second derivative here, because in the differential equation here there is no second order differential equation. So by substitution, you see that we are having a linear what? Equation, and we have n to the what? 2. That is that for the what? The B. So when you go to the C, you should be expecting a quadratic what? Equation, because it involves a first order and what? A second what? Order. The D2, you need to be also expecting a cubic what? Equation, because we have a first order, second order, and what? A third order differential what? Equation. It's not difficult. Take the function, differentiate it the number of times you need in the differential equation, and that is all for that. Thank you. See you in the next video. Please make sure, I encourage you to solve more questions, and trust me, the more you solve, the more you'll be equipped. Alright, as far as this course is concerned, you need to be solving what? More questions. See you in the next video.